Thank you, Jimmy, for the nice introduction. And good morning, everyone. Good evening from Saudi Arabia. We have 8 p.m. right now. And thank you, everyone, for being here. As Jimmy mentioned, my name is Karen Sanchez. I am a postdoctoral researcher at the Center of Excellence in Generative AI at KAUST, the King Abdullah University of Science and Technology in Saudi Arabia. And my work focuses on AI for healthcare, especially in medical imaging, video understanding, and something related with privacy preserving for patients' care. So today I want to talk about a topic that is deeply important to me, the connection between women, artificial intelligence, and the future of healthcare. And this will not a typical technical conversation, it's more a human one. It's about who builds the technologies that will shape how we diagnose, treat, or take care of the people around the world. Because usually we talk a lot in different conferences, seminars about the technical part, about what we need to do, why we need to do some technologies, but I want to focus more on who, especially taking advantage of this amazing invitation from Voxel 51 called Women in AI. I'm very happy to be here because I guess that as women, we have a lot of things to do in this area. So let's start. Okay, I am having a big troubles with my screen. I don't know why. Okay, good. So let's talk about why women matter in AI and healthcare. Let's begin with a simple question. Why do women are important in these areas? Not just as users, but as innovators, leaders, creation of the tendencies. The answer becomes clear when we develop more this conversation. And I will explore the types of data that we have in the medical area, the tendencies, the gaps, and finally, why we are so important in this area. So the numbers across the history clearly show a gap. Let's show you that the girls are less likely to study STEM careers. This is science, technology, math, and engineering careers. So this is not about capability, of course. You and I, we know that the girls, we perform just as well as the boys in these subjects, but this is more about the environment, the encouragement, the culture, the visibility that we as women have. When young girls readily see women leading in technology, outstanding in technology, it becomes harder that they can imagine themselves there in top positions in technology. So this is reflected in the numbers. More than the double of the people involved in STEM careers are men, not women. But the problem doesn't finish there. The problem is that even when women enter in STEM careers, many leave the field along the way. This is what we call leaky pipeline. At every stage university, master, PhD, or even worse in senior positions, we lost a lot of talented women who could be shaping the future of AI. And the result is a massive loss of potential innovation technology, but most importantly, we are losing a very critical and important point of view when we develop technology. So when we look at the workforce, the gap is very big, as you can see. Women represent just a small fraction of computing and AI roles. That means that most of the technologies that we have around the world, these all amazing creations in artificial intelligence, technology, agent systems, they have a bias in the point of view because they are created more for men. So we are losing the empathy, the ethics, and the human context that the women can bring to this area. And this is not just about a gender opinion, is that this is demonstrated in from the medical field. if we go deep into the differences between genders, the hormones, the configuration of how the brain works between genders, we can find that we are different in the way that we address the problems, in the way that we can solve multitask problems. So this has been demonstrated that we are losing a very important way in solving the problems because we don't have too many representation of women in technology and AI. But there is a very important point that I want to show you, and is that, okay, we don't have too many people or too many women involved in architecture and engineering occupations or in computing and mathematical scientists. This graph just represents the woman percent in occupations, but in contrast, the women always are focused more in education, library, training occupations, and in general in social areas. Sorry, in social areas. So this is represented, or this is motivated for the traditional way in that the women we think. We are more focused on social, on environment, on take care of the people in this maternity do we want to protect all the people that is around us of us. So we have a big space between the technical part and the social areas when we choose which career we want to address. But there is a very good news, and is that AI in healthcare is the bridge that close this gap. So it's for that nowadays there are a representative number of women involved, particularly in the application of artificial intelligence for healthcare, because we are closing this gap between social and technical topics. So I want to show you now, before to continue presenting why the woman apart or the woman have an important point of view for the AI of health for healthcare, I will take a short moment to speak about why healthcare needs artificial intelligence, but I think that you can from yourself think what is the response. Healthcare is, of course, one of the most powerful applications of AI between, if you move to the sustainable development goals, the healthcare impact to everyone around the world. This is applied to everyone around the world. The healthcare impact the lives or every human life. So AI in healthcare can reduce diagnosis times, automate repetitive tasks, and help doctors to make the things faster, more accurate decisions. But maybe one of the most powerful roles of AI is the democratization. With the right tools, countries in low on or middle income countries, they can prevent deaths incorporating technology. According to the World Health Organization, it's estimated that approximately 2.6 million deaths annually in low and middle income countries could be prevented through better access to health technology. But of course, healthcare is also one of the hardest fields for different reasons. To create potential artificial intelligence technologies, we need data. In most of the cases, we need a lot of data. But the regulations that turns around the privacy concerns in the healthcare sectors produce diverse challenges, and is that this data is very scarce. It's estimated that between 11% and 30% of the world's data is generated by the healthcare sector and is growing faster than in any other industry. However, this data is not public, of course, so this is a challenge. We can't access to this data as is very easy in other applications or in natural images. So to overcome these challenges and unlock AI is fully potential in medicine, we need to understand the data that is behind this topic, AI in healthcare. So I want to show you very fast the amazing and rich and diverse information that we have in the healthcare sector. It's not just about X-rays, it's about a lot of different kind of information that we can explore to construct solutions that help to save lives. In medical, inside the topic of medical data, we have the first and most common or most known kind of data is medical imaging. So particularly when I say medical imaging, we are referring to all the set of technologies and processes used to create images of parts of the human body for clinical purposes. So if I take a typical photo with my smartphone just for social media, this is not a medical imaging. It's only when this picture is taken for clinical purposes. So in this area of medical imaging, we have a lot of technologies already developed using AI. For instance, we already have applications to support dermatology, radiographies, mammographies, in the area of histopathologies, segmentation of brain tumors, segmentation of prostate, indeed in applications in interior images present in endoscopies. So there are a lot of algorithms for segmentation, detection, that help to predict, treat, and assist in the diagnosis of disease in medical imaging. But including a new dimension, we also have medical videos. During medical procedures, for instance, in this case, these doctors are doing a laparoscopy surgery. They always have cameras present in these workflows. So this is a very good new or a very good new a very good thing, sorry, for the engineers or for the researchers, because we know that there are data in video or there are video data from the medical sectors, because always that the people did laparoscopy surgeries, they need to record or they need to see the interior of the human body across these cameras. So AI can assist in understanding these scenes. For instance, in this case, you can see AI applications to analyze the optical flow in these videos. One of the most important activities in medical videos is related with detect the tools, the actions, and the tissue. This is called like triplet detection. We need to detect 3 important points in these videos to assist to the doctor, also for training when they are preparing to the new doctors in this kind of surgeries. But also we have other medical kind of the other type of medical data, which is biomedical signals. This is also very common. We have different signal like electrocardiography, electroencephalography, electromyography, which is for the tissues, and one that we use very frequently, which is photoplethysmography, which provides light impulse in the smartwatch, for instance, to measure change in blood volume in the human body. So it works with light impulse, and other things of wearable sensors that allow to acquire information very important for the human body to study the healthcare. Moving to one less common type of data, we have the omics one. This omics data is generated by high throughput technologies that I analyze biological systems at the molecular level. So it's for that it is very different. This omics opens the door to personalized medicine with genetic and metabolic insights. This omics data is, for instance, which was used by the AlphaFold project, which was developed by the Nobel Prize winners in chemistry and physics 1 year ago. So this is critical also for more particular and deeper, for instance, in the development of new drugs, they need this kind of data. So this is to show that the concept of AI in healthcare is a very big space. Finally, we have the clinical text, which is called the medical reports. Is all the related with the documentation, summaries, decision. AI can help in or can assist in decision makings, in generate automatically radiological reports of X-rays, and also we can incorporate this text in multimodal systems that can combine different types of data in one only system that is more robust and can generate better alternatives or better solutions to support the AI systems technologies. So in this example that I have here in the left is one paper that combines mammography images with text data from the patients and can predict with 3 years in advance the presence or that will appear breast cancer in the future in women. So in this topic of AI in healthcare, there are a lot of opportunities, but also a lot of challenges. So I already mentioned a lot of type of data, but I want to show you how can we organize all this diversity in three columns or in three main applications. How can we organize the space of AI in healthcare? According to Andrew Ng, he said that we can divide AI in healthcare in prediction, diagnosis, and treatment. When we create algorithms or solutions, or when we are creating a new data set, usually we can categorize this data set or this solution or this research paper, let's say, in one of these three categories. We want to predict disease, we want to diagnose in real time, or we want to assist the treatment of disease. Here I put some examples. For instance, in prediction, one example is the combination of mammographies and text to predict with 3 years or 3 years before the presence of breast cancer. Diagnosis is the most explored one, in which we can detect, segment in real time disease in different types of images or videos or something like all the types of data that we want. But the third one is the less explored one currently and is the related with the treatment. When already appears the disease, we need to help, for instance, to drug discovery using AI models or help to share time with the patient or follow up the evolution of the disease with the patient across the time. So the solutions are less common. But I want to mention three big challenges that we have in this area. There are more, maybe, I think so. But I want to focus on three challenges that I want that you remember if you want to explore in this area or if you are working in this area. I guess that it will be useful if you remember that one of the main challenges is the data scarcity, because this is private, this is isolated, this is very scarce, it is very expensive label this data. But fortunately now we have Voxel 51, so I guess that in other meetup sessions similar like this, you can also know more about how Voxel 51 can help us to label data, because we really need that. So this is a very important challenge. So I invite you to think about this and think in solutions that can help us to fit with this problem. The second challenge is the distribution shift. Different hospitals produce very different data, making that generalization of algorithms is extremely difficult. Deep learning classifiers are well known to overfit to a particular data domain in which you train your algorithm. The algorithm usually will overfit about this distribution. So it's common in the healthcare sector that the data vary for diverse variables. For instance, for technological reasons, because we have different equipments in the different clinical centers. Also for demographic reasons, because the human, the context of the patient morphology vary between the different regions of the world. So this happened, for instance, in one paper that we were working, that we trained one algorithm in one data set from China, but when we test or did inference in one data set from France, the accuracy of the algorithm is lower than in the domain of the training source. So this is the main problem, or this example can show you why this is important, because the distribution of the data vary between different places. So the third challenge that I want to share with you is the hallucinations in VLMs. Currently is going each time more known the presence of agents or VLM models to generate information that can automatically generate reports in radiologies. But this information that is not factually grounded in the medical image sometimes, so this is very dangerous and is a critical research area nowadays. We don't want that the VLMs produce hallucinated information or that they produce false positives in the reports, because this is very dangerous for the people. So we need to mitigate these hallucinations. It's a very hot topic nowadays in research. We also, I want also to share with you some real world or examples in which I have been working in my last years. I will try to be very fast in this section, just to show you that always that we speak about AI in healthcare, we usually mention algorithms, technology, GPUs for training, all of that. But in AI for healthcare, the center in all of that is the patients. We are working for humans, we are working for people. So this is why women are important here. This is one of my favorite projects. In Colombia, I lead the development of a chronic wounds assessment platform that helps doctors track severe wounds over time using just smartphone cameras. So this project allows us that the medical doctors in Colombia, even in rural areas, take pictures of chronic wounds in leprosy patients, because unfortunately this is a disease that is present in Colombia, and particularly in my hometown, in Contratación, in the Santander state. So we have there more than 200 patients that travel from around all Colombia to Contratación to receive special treatment. So the medical doctors from Contratación use this platform to can follow up the evolution of the chronic wounds across the time. Yet they receive AI real-time analysis of the perimeter, area, and types of tissue that compose the chronic wounds. So in this way, they can have an organized register of all the patients, but also they can have a second opinion about how is changing the tissues of the chronic wound. And in this way, they can take better decisions about the topics that they use in the treatment of the patients. Nowadays, we publish a data set which is called CO2 Wounds B2. This is available you can download this data set. This contains more than 700 images. All of them have detection and segmentation labels, which were produced by the expert doctors from Contratación. Nowadays, they have processed more than 1,500 images of leprosy patients in this platform. Now we are working with the medical doctors from the Hospital Simón Bolívar in Bogotá, which is the largest burn hospital unit in Latin America, because we are moving from chronic wounds caused by leprosy now to chronic wounds caused by burns. So we are extending this project right now. The idea is that now the medical doctors from the Hospital Simón Bolívar can follow up the patients that receive burns for different situations, electricity, hot water, hot liquids, and even acids, and receive a better treatment supported by AI. I'm also working in video understanding for laparoscopy procedures, as I mentioned in one of the types of medical data. I blurred this image because it's a bit sensitive for some people, but the idea is to detect the instrument, verb, and target that we have in each frame of the video to produce a more accurate, because these videos looks very homogeneous across all the videos. So we need to support with labels and some captions for educational purposes. I'm also working in detection of hallucination and how to mitigate this problem. Even we will submit this paper in some hours to CVPR, because we have today the deadline of CVPR. So I want to say good luck to all the people that is submitting to CVPR today. And finally, I want to mention the importance of 3D representations of organs, anomalies, and structures. So we are, with the pass of the time, we want always to incorporate a new dimension. We always want to explore more dimensions in technology. So I'm moving beyond traditional 2D images toward 3D anatomical representations, opening new possibilities for diagnosis, treatment, and representation of 3D anatomies and structures for the healthcare sector. I want to close with a sentence of Sophia Hoyer. She is a great gender and social inclusion leader, and she says that to achieve the next generation of global development goals, we need gender equality in research and innovation. So from my point of view, the perspective that summarizes my own perception of AI in healthcare is that we need to remember always that the heart of innovation doesn't lie in the machines, but it's in the people who design that technology. So when more women are part of that process, innovation becomes more human, more ethical, and more powerful. So the future of healthcare will be built with algorithms, that's true, but led by people. And the future we want requires more women building it. Finally, quick invitation. In collaboration with 3 amazing women, we're organizing the Women in Computer Vision workshop for CVPR 2026. One of the organizers is Paula Ramos, who will be one of the speakers today. So we invite you to follow us on Twitter, where we will be posting more information about this workshop. Thank you very much to all of you for attending this talk, but especially thank you to Voxel 51 for creating this very, very important space to talk about women in AI.